Hey everybody, Portland Chess Shop here to bring you the chess action, and I'm going to be showing you a little bit about the mathematics of the bishop. Let's calculate a few moves ahead with the bishop, see how many possible squares it can move to. So, with the bishop on g7, this is the classic fianchettoed bishop, right? So the bishop is fianchettoed, and I've talked a few times about how the bishop is pretty optimally placed when fianchettoed, and I want to kind of explain why. So here it has 1, 2, 3, 4, 5, 6, 7, 8, 9 different squares that it could move to. Okay, so from this point it has 9 different squares that it could move to. Good to know. What about the bishop on some other squares? So let's take some of these things off. Let's give us a bishop over, let's see, over here. So this is the fianchettoed bishop versus the bishop on the side. So here it has 1, 2, 3, 4, 5, 6, 7. So 7 over 9. That's clear. 7 divided by 9 equals 0.777. So the bishop is approximately 4/3 as strong in this position as it is in this position. That's actually pretty good odds for this bishop. So let's check out a couple other possibilities. The bishop could be centralized. Let's see. So we have to take it off and center it. Okay, so from here it's going to have even more possibilities. It's going to be pretty good in this position. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 different possibilities, and I think that this is going to be the maximum number of possibilities that a bishop's going to have 13 possible squares that it could move to in one turn, which is actually a lot more than the knight, right? Because the centralized knight has 8 possible squares. So a centralized bishop versus a centralized knight. So the knight is approximately has 6/10 of strength as a bishop, which is really, in a classical academic grading, the knight would be getting a D, while the bishop would be getting an A+. In some sense, because the knight, in some sense, with 8 possibilities versus the bishop's, what did we say, 13, right? 3, 6, 9, 13 possibilities. So it's going to have that much more effectiveness. So let's check out the bishop over a couple different moves, though. So 13 possibilities within one move, but what about within 2 moves from this position? So let's sort of draw it all out. And this makes a pretty picture, right? It kind of shows you exactly what the bishop does, which is why I think this is a little bit instructive. So along this diagonal, it's going to then have 1, 2, 3, 4. So the bishop can't move to the same. Ooh, the bishop's going to have a lot of possibilities within 2 moves. Because I'm just looking at this, and it's going to have this and this also. Wow. So it's going to have. This is actually going to be kind of hard to count. Because think about it. It's going to have lines across here, across here, across here, across here. And so the bishop's only going to be able to move to 2 different. There's going to be a lot of different ways that this bishop could move within 2 turns. This is all within 2 turns. I mean, notice that they're obviously all dark squares, which is, one of the advantages of the knight, is that the knight can move, on both colors, while the bishop can only move on one color. But look at all these different possibilities that the bishop's going to have. It's going to just overlap like crazy. Within 2 moves, it's going to have tons of squares. And obviously we're making a lattice, which I think is actually the mathematical term for it, like even topologically speaking. Topology is an advanced form of mathematics that you learn about like in graduate school that has to do with the study of spaces. And a lattice is a concept in topology. And this is exactly what a lattice is this like crisscrossing, intersecting structure. So let's pull this bishop off and use a new bishop and try to get the number of squares that it can do within 2 moves, which is really going to be kind of giant. So we decided it's 3, 3, 3, and 4 makes 13, which is an odd number, which is kind of interesting. And then even if it can only move on this same line, then it would have, from here it would have 1, 2, 3, 4, 5, 6, 7. Okay, so from this square, it has 7 more possibilities. So I'm going to have to grab the calculator. So all we've calculated is this square, and we got 7 already. Okay? Plus, okay, so let's go to this square. So from this square, it's going to have 9. It's going to have 7 different possibilities across this diagonal, plus this square and this square. So that's 9. So plus 9, and we get 16. Now let's go with this square. So this square, it's going to have 7 across this diagonal, right? Plus 4, okay, which is 11. 16 plus 11 equals 27. We've covered that square. So the bishop couldn't be on this square because it already moved once. So we get to skip the square that it started on and then jump to this square. So from here, it's going to have 7 across this diagonal again, plus 6 across this diagonal, which is 13. Plus 13 equals this number, 40. Now we're going to do this. This square is symmetrical to this square, right? So it'd be interesting to see the kind of the number theory to it, because you're going to be able to make like an exact mathematical pattern to how many possibilities. But anyway, from this it's going to have 11, right? Because 7 across here plus 4 across here. Excuse me if I mess up any of the math, because I've been, you know, it's a Friday night and I've been having fun. So 9 possibilities across this square. So plus 9 equals 60. And then 7 possibilities from this square, plus 7, 67. So remember that the knight had 56 possible squares within 2 moves from the center, and the bishop has 67 already, and we've only analyzed one of the lines. So you can see that actually, you know, when they say that the knight is equal to the bishop, I think that that is not true. I think that that's like blatantly false. I know Bobby Fischer said it, but it's just, that's just not the way it is. The bishop is more powerful than the knight, especially on open boards. I mean, the knight can cover both colors of squares, but at least on an open board, the bishop just has so many more different possibilities. So let's check out this bishop for another moment. We have 67 possibilities across this diagonal, but what about from here? So here we're going to have 1, 2, 3, 4, 5, 6. 6 plus this square is 7. So we're going to go plus 7. All right, we're at 74. Now we're going to calculate this square. It's going to have 6 across here. 1, 2, 3, 4, 5, 6. Plus 3 is 9. So 74 plus 9 equals 83. Now here it's going to have 5 plus 6 is 11. All right, and then from here it's going to have 5 plus 6 is 11. From here, this is similar to this, right? It has 3 plus 7 is 10. And then from here, it's going to have 1 plus 5 plus 6 is 7. So I might have messed up the math a little bit, but I think this is generally correct. And we have 122 possibilities within 2 moves, which is, I'm really surprised at. That's a much bigger number than I expected. And the reason why I'm surprised is because, look at this, 56, that's the number of possible moves that the knight has, over 122, and we have 0.459. So the knight has like 46% of the possibilities that a bishop has within 2 moves. So 2 moves within a bishop is, I don't know, has more possibilities than 2 knights, each with 2 moves, right? Because the knight, the centralized knight, one of the centralized, yeah, let's I want to sort of show that point. So this knight and this knight, all right? So they're both centralized knights. So this knight's going to have 56 possible squares that it can move to within 2 moves. This knight's going to have 56, but this bishop's going to have 122 possibilities within 2 moves. So this bishop has more possibilities within 2 moves than both of these knights combined, which is really kind of mind-blowing. So 45%. The knight has 46% of the strength of the bishop in some sense within 2 moves. But let's even check it out as the odds. So 122 divided by 56, and now we get 2. So the bishop is in a, I don't know, using odds from probability is almost like a 2-to-1 favorite in the number of possibilities, at least, that it has. So I just kind of wanted to let you guys start to think about the mathematics of chess. Think about what are some of the possibilities, not just within one move, but within multiple moves, and how do the pieces, geometrically, what is their nature? What is their characteristics in some sense? So it's almost a little bit of a philosophical question within the mathematics of chess. So hope you appreciate it. Please thumbs up my videos. Watch a lot of them if you can. But the thumbs up really helps me. It gives me, it gets more views, and more views is more happiness from my chess life. I'm here. I'm the Johnny Appleseed of chess. So thanks for watching. Appreciate it. Bye.